Hi everyone, today I want to talk about Dorna 2 Python API and give you guys a quick tutorial on how to program your robot with Python. First, go to the support section on top, Document Center, and then API page. Here is where you can find all the materials for our Python API. We're hosting the code on GitHub, so in order to download the API, you can either download the zip file from the GitHub or just directly git clone the repository on your computer. After downloading the API, we need to install it so it's visible by Python. Go to the downloaded folder and run python setup py install with force option. Before I start coding, let me open a Dorna lab page so we can monitor the robot on our browser and see the API and robot interaction. Let's connect first. The IP address of this robot is 192.168.110 and the port number is 443. We are connected, and let me minimize all the pages so we have a good overview of the robot and code. And we open a new Python file to write our code there. The module that we just installed is called Dorna 2, and inside this module there is this class named Dorna. Dorna is the main class that we use for interacting with the robot. So from Dorna to import Dorna. Dorna is the main object that we are using here, and let's define our code inside the main function. The first step here is to create the Dorna object. We call the object robot. We need to connect to the robot, and for that we're using the connect method. The connect method takes two arguments. The IP address of the robot we're connecting as a string, and the port number of the robot. Here we're connecting to the same robot as we have on our browser. So the IP is 192.168.110 and the port number is 443. Let me print connected after we connect it to the robot. The robot uses a WebSocket server to communicate with all of its clients, including here, for example, the API on the left side or the web app on the right side. And the messages received or sent by the robot are in JSON format. We use play method in the API to send a command to the robot. The play method takes multiple inputs. The input variables here are the key inside the JSON command that you're sending to the robot, and the value assigned to these variables are the values assigned to those keys in the JSON. For example, here we're commanding the robot to perform a line move and go up 100 mm in Z direction. Make sure you're familiar with Dorna's set of commands. Here the command is lmove, relative is equal to 1, and z is equal to 100. We also set the velocity, acceleration, and jerk of the motion. We're also adding an ID field to track the completion of this command. The ID field is not necessary, but if you're adding it, it has to be a positive integer number. For example, we're setting it equal to 1 here. A command with a given ID is completed by the robot if we receive a confirmation message from the robot with the same ID and a set equal to 2. In this case, we're using the wait method with ID equal to 1 and a set equal to 2. I'm going to explain the wait method later, but here the wait method does not return anything until the above motion command with ID equal to 1 is completed. So after we waited, let's print motion is completed. We use close method to close an open connection. Always make sure to close and open connection at the end of your code. That's it. We connect, we send a motion command, we're waiting for the completion of that command. This is basically a while loop, so it doesn't go after the print if it's still waiting. After the motion is completed, it will print, and at the end, it will close the connection. Let's run this. As you can see, the robot goes up 100 millimeter in Z direction. Let's make our code a little bit more complex by running it in a for loop. Each time, depending on the index of the loop, the robot either goes up or down. We also have a unique ID number assigned to each motion to wait for its completion. Notice that the IDs are I plus 1 to make sure that all of them are greater than 0. As you can see, the robot goes up and down for 10 times. Notice that the wait method is not necessary here. We used it because we wanted to wait for completion of each individual command. So if you don't care about that, just comment it, and your for loop probably takes few milliseconds to send all those 10 motion commands to the robot. Next, I'm going to talk about the messages we're receiving from the robot and how to process this data. Notice that the robot sends messages to all its listeners in a JSON format, and sys is a Python dictionary that updates itself according to these coming messages. Let me actually print sys for better understanding. We call the function main sys, and for 10 seconds we're going to print the sys dictionary. Notice when I'm jogging the robot, the sys dictionary is changing. And if you go over one of these objects, you'll see we have the joints value, XYZ value, latest command, latest ID, latest stat, the alarm status, tool links, and input, outputs, and many other things. So basically, sys holds the latest keys and values that are received by the API. Now let me explain what is the wait method. The wait method is a while loop that basically breaks when it finds the input patterns in the sys dictionary. If someone is interested in the individual messages received by the API, then we're introducing MSG. MSG is a Python queue of size 100, and it holds the latest 100 messages received by the API. Notice that each element in MSG is a Python dictionary. So let's print the messages that we are receiving from the robot, and we are going to do that for 10 seconds. So every time in the while loop, we have to first make sure that the robot MSG queue is not empty. And if the queue is not empty, we're going to get the first element from the queue. These are going to be many messages, so we're only interested in the messages that are related to the IOs. And if you're familiar with the robot commands and messages protocol, we're only interested in the messages with CMD key equal to output. So every time we're changing the IOs, we're receiving a message from the robot and we're showing it in the command line. Now that you're familiar with the wait method, let me do another thing. Actually, I have connected the output 0 and input 0 with a wire on the controller box. So they're basically synced together. If I change the output, the input also changes. So what I'm going to do now is waiting for input 0 to turn on. And after that, the robot is performing some motion. So the way to turn on input 0 is by turning on output 0 on Dorna Lab. Let's rewrite the main function for that purpose, and we're running the for loop only 2 times. And all we have to do is call the wait method with in0 equal to 1. Let me sleep here also for 2 seconds so we have time to see the motion. As you can see, we're waiting for input 0 to turn on. We are triggering the output 0. The wait method breaks and the robot moves twice. Here I tried to give a quick tutorial on the Python API, but please visit our document center page and read the documents there. If you had any question or issue about the Python API, please visit our GitHub page and post your issue on the issues section of the GitHub page. Also, make sure to follow our page and get the latest updates on the API. Thank you very much and have a nice day.